Have you ever wondered what a megawatt solar project looks like? The array uses 1,710 bifacial TOPCon all-black modules, each rated at 585 watts. These are N-type monocrystalline modules with about 44 volts at maximum power, about 13.2 amps operating current, and bifacial gain potential, up to roughly 15% when the site design supports rear-side reflection. Across the field, the modules are installed on a ground mount racking system with single-axis tracking. The structure uses galvanized steel posts, rails, clamps, and proper row spacing with enough clearance above grade to support airflow, maintenance access, and rear-side albedo gain. On the DC side, the array is divided into strings of 18 modules. Each string operates at roughly 790 volts at maximum power. Open circuit voltage is about 950 volts at standard test conditions and can exceed 1000 volts in cold weather, which is why string length must stay within the inverter's maximum DC voltage rating. At this scale, the system has about 95 DC strings, with PV wire routed through organized wire management, labeled conduit, and home-run conductors to string combiner boxes and inverter inputs. The combiner boxes include fused inputs and surge protection, and lockable DC disconnects provide safe isolation for maintenance and emergency procedures. Power then moves to 4 250 kilowatt three-phase commercial string inverters. Together, these provide the full 1000 kilowatts of AC output. Each inverter includes multiple MPPT channels, typically 10 to 12 trackers per unit, with input ratings high enough for bifacial module current. Compared with a central inverter approach, this string inverter layout improves MPPT granularity, simplifies service access, and supports modular expansion or replacement. On the AC side, each inverter feeds through AC, disconnects into a 480-volt three-phase switchboard in the 1600 amp class. Type 1 or Type 2 surge protection is applied on both DC and AC sides, and all equipment is bonded with grounding conductors, ground rods, and properly labeled grounding paths. A revenue-grade production meter records energy output before the system steps up through a pad-mounted transformer, typically from 480 volts to 12.47 or 13.80 kilovolts. That transformer is a key difference from the smaller 100 kilowatt system because a 1 megawatt project usually connects at medium voltage before reaching the utility point of interconnection. Finally, monitoring ties the whole system together, showing real-time kilowatts, accumulated kilowatt hours, alerts, and string-level performance data. Learn commercial solar design at ecotechtraining.com.